Imagine this. The oldest star map we've ever found might be pointing us to somewhere nobody's ever bothered to look. Picture a tiny clay seal pressed into the earth 4,500 years ago, hiding the answer to where the Anunnaki said they came from. Right now, in a basement vault under Berlin's Pergamon Museum, there's a cylinder seal about the size of a wine cork, just sitting behind glass nobody pays much attention to. Most people walk right by it. Its catalog number, VA243, means absolutely nothing unless you're deep into ancient history. But here's the thing. This little object, dug up from the ruins of a Mesopotamian city that disappeared 3,000 years before Christ, shows an image that shouldn't even exist. It's an astronomical diagram that's so sharp, so weirdly advanced, it throws everything we thought we knew about ancient stargazers totally off balance. Before we wander too far down this path into the desert night, do me a favor, like this video and subscribe. If you're the kind of person who gets pulled in by mysteries that sleep between starlight and clay tablets. And if you're still with me, drop a comment. Tell me where you are, what time it is, and if the sky above you is clear enough to spot anything like what the Sumerians saw. I want to imagine this story stretching across time zones, whispered in the dark while those same constellations still turn overhead. Now the seal itself doesn't look like much at first. It's a small, dark stone cylinder, maybe 3 inches tall, worn smooth by centuries. Back in the day, you'd roll it across wet clay to leave an impression, a signature, a badge of ownership or power. Archaeologists have found thousands of these things all over Mesopotamia. Most show everyday scenes, rituals, kings meeting with priests, gods handing out blessings. Nothing out of the ordinary. But VA243, totally different story. When researchers first pressed this seal into clay to see the full scene, everything stopped. Right in the center, you've got a tall, robed figure sitting on a throne, classic Akkadian style, so we know it's from around 2400 BCE. To the right, a smaller figure comes forward, arms raised, maybe asking for something or just showing respect. So far, so normal, but look up in the top left corner and things get weird. There's a star, but not just any star. It's not decoration, not some symbol for a god. You see a central orb with 11 smaller spheres circling around it, arranged in a way that feels oddly familiar if you've ever cracked open a book on astronomy. It looks just like a solar system, our solar system, with all the planets. The thing is, the Sumerians weren't supposed to know about most of those planets. They had no telescopes, no centuries of star charts. Saturn was the farthest planet you could spot with the naked eye. And yet on this stone, there are more spheres orbiting a central sun, all carved with real intent, like someone had drawn a map of the sky from a place no ancient human could have stood. When scholars first got their hands on the seal in the early 1900s, they cataloged it and stuffed it away. The notes just say, celestial motif, significance unclear. It sat in the archives for decades, sometimes photographed but mostly lost in the flood of Mesopotamian artifacts needing study. Then in 1976, Zecharia Sitchin, a journalist, not an archaeologist, but a guy who'd spent years digging through Sumerian texts, published The 12th Planet. Overnight, VA243 went from forgotten to infamous. Sitchin didn't hold back. He argued that the big sphere in the middle was our sun, and the 11 smaller ones were the planets, including one extra world he called Nibiru, the home of the Anunnaki. According to him, the Sumerians had mapped out our entire solar system, including planets we didn't officially spot until centuries later. Uranus in 1781, Neptune in 1846, Pluto in 1930, even if it's not a planet anymore. For Sitchin, this seal was proof that someone in ancient Mesopotamia knew things they just shouldn't have known. Unless, of course, they'd been told. Unless someone showed them. Unless the truth came from somewhere way out there. Scholars didn't waste any time. They shot down the idea right away. They argued the seal's imagery is a Rorschach test. You can see whatever you want in it. Maybe those spheres are stars, not planets. Or maybe they're just symbols, not meant to be taken literally. Some even suggested they had nothing to do with astronomy at all. Maybe they're religious or mythological, something else entirely. And good luck counting them. Depending on how you look at the seal, you count the half-hidden circles on the edge. Do you treat the big ones differently from the small ones? You get 11, 12, 13 spheres. The critics said the interpretation felt forced, like someone was bending the evidence to fit a story they already wanted to tell. Dr. Michael Heiser, an expert in ancient Near Eastern languages, really went after Sitchin's theories. He pointed out the seal doesn't have any labels, no text naming the spheres as planets, no clues that this is about astronomy at all. If you insist it's a solar system map, he said, you're ignoring everything we know about Mesopotamian art. In their iconography, circles usually mean stars, deities, or just some abstract idea of the heavens, not planets lined up in order. The seal's design, Heiser argued, looks like typical Akkadian religious art, not an ancient scientific diagram. But then some uncomfortable questions started piling up, questions that didn't fit so neatly into the easy dismissal. Even though VA-243 is a weird, standalone artifact, it isn't the only sign that Mesopotamians were serious about astronomy. The Sumerians, Babylonians, Assyrians, these people were brilliant sky watchers. Nobody argues with that. It's all over the historical record. Archaeologists found stacks of clay tablets in Nineveh, astronomical diaries that stretch across centuries. They tracked planets, eclipses, the movement of stars with accuracy that blows you away. It took generations of careful observation and math to get results like that. The Babylonians figured out Venus's synodic period, 584 days. Modern science says it's almost exactly that. They tracked Jupiter's orbit at 11.86 years. We now measure it at 11.862. They predicted lunar eclipses using the Saros cycle, an 18-year pattern that repeats eclipse sequences, a discovery Europe wouldn't catch up with until Halley, nearly 2,000 years later. This wasn't just luck. This was methodical, relentless sky watching, passed down and refined by scribal schools whose whole job was to keep the records going and push the knowledge forward. The precision they achieved points to a huge institutional commitment, resources, expertise, generations building on each other's work. So here, where the real mystery creeps in. How old is this tradition really? Most of the tablets we have come from the first millennium BCE during the Neo-Babylonian and Persian eras. But those documents often talk about even older sources. They copy from ancient texts, and they say they're preserving the work of skywatchers from centuries, even millennia before. There's Berossus, a Babylonian priest writing in the 3rd century BCE, who claimed their astronomical records went back over 400,000 years. Scholars today laugh that off, just priestly bragging, a wild exaggeration to sound impressive. But maybe the number isn't meant to be taken literally. Maybe it's symbolic, cycles, epochs, some kind of lost timekeeping system. Maybe buried in that wild claim is a memory of a tradition so ancient that even the Babylonians had lost sight of where it really began. The Sumerians counted with a base 60 system, a sexagesimal method that still runs our clocks and keeps our circles turning. 60 seconds in a minute, 60 minutes in an hour, 360 degrees in a circle. It's everywhere, and it shows up fully formed in the oldest Sumerian records. There's no evidence of trial and error or earlier, simpler systems. It just appears, woven into their world from the start. And honestly, it's genius for astronomy. 60 divides cleanly into more pieces than any smaller number, which makes tracking planetary cycles, eclipses, and mapping the sky so much easier. Someone set this up with stars in mind. But who did it? And when? What exactly were they hopping to figure out? When archaeologists dig up Mesopotamian tablets, they find star catalogs, lists of constellations, notes about where they rise and set, how they fit into the changing seasons. Some of those star patterns are still familiar: Taurus the bull, Leo the lion, Scorpius the scorpion. The Sumerians named them ages before the Greeks made the zodiac official. But some tablets go further. They talk about the planets in ways that make you pause. The MUL.APIN series, a Babylonian text, describes the paths of planets as seen from the height. Not from a hill, not from a ziggurat, but from high above. Like someone's looking down over the whole solar system, not stuck with the ground-level view everyone else had. Scholars usually call this poetic, a way to talk about the gods' perspective. But the rest isn't poetry. It's numbers and relationships, planet to planet, orbit to orbit, cycles and ratios. Details you'd need a bird's-eye view or maybe something more to actually see. Either they watched from somewhere impossible, or they learned from someone or something with a wider vantage point. And then there are the texts that get specific about where the Anunnaki came from, not just in symbols or metaphors, but with what reads almost like coordinates. The Enuma-Elish, Babylon's story of creation, lays out a universe filled with named celestial bodies. Tiamat, the ancient ocean; Apsu, the fresh water; Mummu, the mist; Anshar and Kishar, the horizons; plus Lahamu and Lamu, described as planets born before Earth. Gods like Anu and Lil and E each get assigned to their own regions of the sky, described with actual directions, not just flowery language. Marduk, the chief god, crosses the heavens, sets up stations, fixes the paths of the gods. He places the stars, organizes the constellations, divides the year, and gives each month 3 stars. This isn't just myth. It reads like someone mapped out the sky, assigned spots, traced orbits, brought order where there was chaos. Today, we call these stories myths. We say the Sumerians just projected human ideas onto the skies because they couldn't explain what they saw. But that's not how they saw it. To them, works like the Enuma-Elish were annals, records, not fiction. They copied them carefully, repeated them every new year, treated them as the true record of how everything started. Not a guess or a metaphor, but the story as it was passed down by those who claimed they remembered. In the Epic of Etana, there's this wild story about a king who wants to reach heaven to find the plan of birth. The way they describe his journey is surprisingly detailed. As Etana rises, the earth below keeps shrinking. First, the land looks like a hill, then it's just a garden, then it's as tiny as a bread basket. The sea, it shrinks down to the size of a water trough. Eventually, the whole planet just vanishes from view. It sounds exactly like what astronauts talk about when they leave Earth's atmosphere. The world getting smaller and smaller, continents turning into vague shapes, and finally, nothing but space. How did a Sumerian scribe, writing 4,000 years ago, know what Earth would look like from above? How could they describe this kind of departure so step by step, so precisely? Most people chalk it up to imagination, maybe a lucky metaphor or just poetic flair. But honestly, the sequence is too spot-on. It lines up with the real experience of gaining altitude, not something you'd expect from a random guess. So, what's going on? Did the writer hear about this from someone who'd actually made such a journey? Or maybe the story is preserving some old knowledge from a source with a perspective no earthbound person could have. Then there's another odd detail, the Anunnaki and how they're described moving through the heavens. They don't just live up there in some unreachable realm like later religions would put God. They have specific addresses in the sky. Anu's home is up in the highest heaven, linked to the celestial North Pole. Enlil rules the middle heaven, the place where weather happens. E or Enki governs the Abzu, which sometimes means the underground ocean, but in old astronomical texts, it might actually mean the depths of space, beyond Saturn, out where the planets disappear from view. So if the Anunnaki are tied to real places in the sky, and if their trips to Earth are described like actual journeys with stops along the way, then you have to wonder, where exactly did they come from? What point in the cosmos did they start their descent to Earth? Sitchin had a bold answer: Nibiru. He said it's a mysterious planet, the 12th in the solar system, with a long stretched-out orbit that brings it close to Earth every 3,600 years. He based this on his reading of Sumerian texts, which mention Nibiru, a crossing point, a planet that moves through the orbits of others on its huge path. Sometimes, old texts link Nibiru with Marduk, calling it the planet that holds the crossing of heaven and earth. In other records, Nibiru gets mixed up with Jupiter, the biggest planet called the king of the heavens in Babylonian tradition. But sometimes, Nibiru seems like something else, a wanderer that shows up and disappears over long stretches, definitely not one of the regular, visible planets. Sitchin argued that's because you just can't see Nibiru most of the time. It spends ages way out past the outer planets, lost in the dark, and only swings by the inner solar system every few thousand years. When it does, it would be impossible to miss. A giant planet crossing the sky where nothing's supposed to be. Then it's gone again, not to return for another 3,600 years. Sitchin claimed this explained why the Anunnaki appear in Sumerian stories on a cycle. They come when Nibiru is closest. They stick around for a while, do whatever they came to do, and then leave as their planet swings away into the depths of space. Humanity's left behind, but not empty-handed. We get knowledge, technology, the roots of civilization, handed down during those visits, remembered in texts and myths that over time turned into religion as the Anunnaki faded from living memory. Most astronomers completely dismiss the Nibiru idea. Honestly, there's just no proof that a giant planet orbits the sun every 3,600 years. If something that big existed out there, its gravity would tug at the other planets in ways we'd have noticed long ago. The math doesn't work out and observations flat out contradict it. If Nibiru were real, we'd have found it by now. Or would we? In 2016, two Caltech astronomers, Konstantin Batygin and Mike Brown, shook things up. They published a paper in the Astronomical journal about Planet Nine, a possible massive planet lurking way out in the solar system, maybe 10 times heavier than Earth and orbiting 20 times farther from the Sun than Neptune. They didn't spot the planet itself. Instead, they noticed something weird. A bunch of distant, icy objects past Neptune were all moving in clustered orbits, as if something big and unseen was herding them along. Their calculations suggested Planet Nine takes between 10,000 and 20,000 years to complete a trip around the Sun, not 3,600, but still, the idea stands. A huge, hidden planet could be out there, quietly shaping the solar system for centuries without us realizing. A discovery like that would blow open what we think we know about our solar system. It would prove we're missing something major, that our maps leave out a big piece of the puzzle. Now, flip that around. Imagine a civilization that started out knowing the outer planets first, mapping the solar system from the edges inward, watching Earth from the perspective of those distant, frozen orbits, only getting closer later on. Their maps would look totally different. To them, the outer planets would be the main players, and Earth would be just another small dot tucked inside. What if that's what we're seeing on VA 243? Maybe the central sphere on the seal isn't the Sun at all, but a viewpoint from far beyond Saturn, with the other circles showing the inner solar system as seen from way out there. The deeper you dive into Sumerian astronomy, the stranger things get. They described planetary retrograde motion, the way planets seem to move backward in the sky when Earth passes them, with a level of detail that's hard to explain. They knew Mars goes retrograde every 2 years. They tracked Jupiter's retrograde, which happens every 13 months. You can't get that just by watching the sky. You have to understand why it happens, which means grasping heliocentrism, the idea that Earth and the other planets orbit the Sun, and that this movement causes the retrograde illusion. The ancient Greeks wrestled with this for ages. Ptolemy came up with epicycles, planets looping in little circles on bigger circles, to keep Earth at the center. Copernicus finally put the Sun in the middle, but it still took Galileo and his telescope to really settle the argument in the 1600s. But the Sumerians, they shouldn't have known about retrograde motion if they really saw Earth as the unmoving center and the sky spinning around it. Yet their records describe planetary motion in a way that only makes sense if you realize Earth moves, too. One clay tablet in the British Museum, BM 45728, even includes calculations for Venus's synodic cycle that only work if you know Earth takes about 365.25 days to orbit the Sun. They understood the leap year problem, that extra quarter day each year that builds up and throws the calendar off, and they fixed it by adding extra months to their calendars, so lunar months and solar years stayed in sync. That's serious timekeeping, and it only works if you know Earth is moving. Then there's something else. Some Babylonian star catalogs place constellations in spots that don't match up with where they should have been visible when those texts were written. The difference is tiny, but you can measure it, and it lines up with axial precession, the slow wobble in Earth's axis that gradually shifts the positions of stars over thousands of years. Nobody officially clocked axial precession until Hipparchus came along in the 2nd century BCE. And even after that, European astronomers took ages to really get it. The cycle itself moves at a glacial pace, about 25,920 years to make a full turn. That means the North Celestial Pole slowly drifts across the sky, and the zodiac constellations seem to slide backward through the calendar over thousands of years. Strangely, the old Babylonian star catalogs seem to know about this. Some of their data doesn't match the sky from 1000 BCE, when the tablets were inscribed. Instead, the positions line up with how the stars would V looked in 4000 or even 5000 BCE. It's as if they were copying from much older records, preserving observations from a time when the constellations sat in different spots because of precession. So what does that mean? Either the Babylonians actually understood precession and adjusted for it, or they were passing down astronomical notes from people who'd watched the night sky thousands of years earlier. Either way, it's wild. On the one hand, maybe they had a grasp of celestial mechanics way before anyone else, centuries before science would officially put it together. On the other, maybe they were the keepers of an ancient tradition, holding onto data that goes back even further than the earliest civilizations we talk about. Then there's this artifact in the Louvre, just a boundary stone, a Kuiper from the Kassite period around 1300 BCE. It's tucked away in storage, hardly ever studied. The stone is covered in symbols: the sun, the moon, Venus, Mars, Jupiter, Saturn. All the usual suspects, the planets anyone could see without a telescope. But then, off in a corner, there are two odd little symbols. They don't match any known icons for the visible planets. Scholars have argued about them for years. Maybe they're stars, maybe just religious doodles. But the way they're positioned, grouped with the other planetary symbols, makes it seem like they're supposed to be planets too, members of the solar system, not just random extras. So could those be Uranus and Neptune? Technically, both are invisible to the naked eye. Officially, nobody spotted them until telescopes came along in the 1700s and 1800s. And yet here they are, maybe, on a stone carved 3,300 years ago, as if the Kassite scribes just knew about them. Most experts say it's a fluke, coincidence, overactive imagination. The symbols mean something else, probably, but the question won't go away. Why would a careful astronomical record add symbols in the planetary lineup if they weren't meant to be planets? The Kassites, like the Sumerians and Babylonians before them, weren't careless. They didn't just slap random pictures onto legal stones. Every symbol had a purpose: legal, religious, astronomical. These stones marked boundaries, called on the gods, proved ownership. Sticking non-planetary symbols among planetary ones would make no sense. Unless, somehow, those symbols really were planets, and we've just underestimated what the Kassites knew. And then there are the cylinder seals. These weren't just jewelry. They were signatures, brands, proof of identity. Some show the sun, but not as a boring circle. Instead, you get a central star with rays, surrounded by smaller circles in what look like orbits. There's one seal, NBC 11097, showing a star with 6 orbiting bodies, each one different in size. Another, VA 563, has 8 spheres orbiting a central one, plus what looks like an asteroid belt, right where modern astronomy puts it, between Mars and Jupiter. That's not just art. Merchants picked seals with trade goods, priests chose religious icons. Astronomers or temple scribes might pick out celestial diagrams. If these seals really show the solar system, with planets in orbit, that means solar system diagrams were normal enough to act as recognizable symbols in Mesopotamian culture. This wasn't fringe stuff. It suggests people thought about the cosmos as a central star with planets circling it, an idea woven into their worldview, not just a weird curiosity. The way we finally figured out the solar system didn't happen overnight. It took centuries, endless nights of stargazing, tweaking numbers, building better tools. Copernicus put the sun in the center in 1543. Still, his idea wasn't perfect. He thought orbits were neat circles. Kepler came along and realized, nope, planets move in ellipses. Then Galileo pointed his telescope at Jupiter and saw moons circling it, not Earth. That was huge. Newton's laws in the 1680s finally made sense of it all, why things moved the way they did. Piece by piece, generation after generation, people chipped away at the puzzle. Europe's best minds worked for 300 years before we landed on the model we teach in schools today. But then you stumble across these images from ancient Mesopotamia, thousands of years earlier, and suddenly, things get weird. Someone there already seemed to know the sun was at the center. They understood the planets moved in set patterns. They even hinted there were more planets than you could spot with your own eyes. And instead of keeping this knowledge to themselves, they carved it into clay, sealed it up, made sure it would last. The real mystery isn't whether the Sumerians and the people who came after them knew their astronomy. They absolutely did. It's proven, it's right there in the records. The real question is, where did they get it? Did they figure it all out on their own just by watching the sky and crunching numbers, jumping straight to insights that took the West thousands of years to reach? Maybe. But it's odd. There's no trail of rough drafts, no half-formed theories, just this sudden burst of advanced knowledge in their oldest texts. Or did they get it from somewhere else? Did someone hand it to them? Someone who wasn't stuck on Earth, who could actually see the outer planets, who understood orbits not just from math but from experience. Someone who'd already mapped the solar system from a place we couldn't reach until we built rockets and left the planet. In the museum, VA-243 just sits there behind glass. It's quiet, a little cylinder of stone, outliving the empire that made it, the language carved into it, the people who once pressed it into clay. But it hasn't outlived the questions. If anything, those questions are louder than ever, because we keep finding things that don't fit, things we can't explain away. Planets where none should exist. Orbits that make no sense unless something unseen is pulling the strings. Distant objects out past Pluto, behaving in ways that break the rules we thought we understood. The solar system's bigger than we guessed, stranger than we imagined, full of things we're only now starting to notice. What if the Sumerians already knew all this? What if VA-243 really is what it looks like? A map, a diagram, a snapshot of the solar system as seen by someone who knew there were more planets than the 5 you can spot from Earth? What if the Anunnaki, those sky travelers in the old stories, were exactly what they sounded like, beings who crossed the stars, set up outposts, came from some far-off orbit that only swings past every few thousand years? What if they mapped the whole thing out, handed down that knowledge, and it ended up engraved in stone, waiting for us to dig it up and try to make sense of it? The wind still sweeps across Iraq before sunrise, swirling dust from cities long buried. Under that dust, under the ruins, more seals are waiting. More tablets, more records pressed into clay by people who believed they were saving something that mattered, something true, something they hoped would outlast them. And above it all, the same stars keep turning, following patterns those ancient watchers named and counted, using math we're only now piecing back together, with satellites and computers, tools they never had but knowledge they somehow found. VA-243 isn't the only map out there, not by a long shot. It's not even the oldest. If you dig around in university archives or private collections, in London, Baghdad, wherever, you'll find scraps and pieces of what might just be the most advanced star catalog anyone put together before telescopes existed. Hardly anyone's heard of it. Most experts brush it off. But if you actually sit down and line up these old texts with modern star charts, the MUL.APIN tablets start to look pretty wild. Suddenly, you realize the ancients weren't just gazing at the sky. They were measuring, recording, and understanding it with a level of detail that makes you stop and rethink what was possible back then. MUL.APIN literally means the plow star, what we now call triangulum, but the tablets are way more than a simple list of stars. We're talking about a full-blown astronomical encyclopedia. The scribes who put these together around 1000 BCE claimed they were collecting ancient knowledge from before the flood, stuff passed down by generations of temple astronomers who kept up the old sky-watching rituals. Inside the tablets, you'll find everything: when each constellation rises and sets, how the sun, moon, and planets move through the zodiac, how to predict eclipses with math, how to track the changing length of day and night through the seasons, even how to use shadows to figure out when it's noon. There are instructions for finding true north and building calendars based on the stars. It's all organized, thorough, and deeply mathematical, the sort of thing you'd expect after centuries of careful observation. But here, where it gets weird, when researchers checked the star positions in MUL.APIN, they didn't line up with the sky of 1000 BCE. The numbers were off, shifted backwards in the zodiac. Not random, though. The shift matched the slow wobble of Earth's axis, called precession, which nudges the stars' positions over thousands of years. When astronomers accounted for precession and rolled the sky back, they realized the MUL.APIN data fit perfectly with the night sky as it would have looked around 2350 BCE. That's about 1,300 years before these tablets were first written down. So what does this mean? The scribes in 1000 BCE were copying much older sources. They were preserving records from the Akkadian era, maybe even late Sumerian times. And somehow, those early astronomers had measured and documented the stars so precisely that their data was still accurate after more than 1,000 years. That's not just impressive, it's astonishing. But the weirdness doesn't end there. Some parts of MUL.APIN talk about star positions that just don't fit with any known period in Mesopotamian history. When you factor in precession, the numbers line up with dates like 4500 BCE or even earlier. So deep in prehistory it's before writing, before cities, before any civilization we'd expect to be tracking the stars with any real method. So what's going on? Maybe the tablets are passing down observations from a much older tradition, way before we thought anyone was doing this. Or maybe someone made some truly wild guesses that, by pure luck, match up with the ancient sky. There's another angle too. What if these observations were made from somewhere else, somewhere at a different latitude? That would mess with the star positions and explain why they don't match Mesopotamia's own viewpoint. Dr. Hermann Hunger, he's a big name in Babylonian astronomy at the University of Vienna, has actually pointed out these oddities in his work. He stops short of guessing where they came from, but he's pretty clear on this. The data is older than the tablets themselves. How much older? Nobody really knows. Maybe some parts are a mashup of observations from different places, all shoved into one catalog. Or maybe some sections aren't real records at all, just scribes doing the math, figuring out what the sky would have looked like ages before. But then, why bother? Why go through the trouble of working out what the stars looked like thousands of years earlier unless you were trying to save knowledge from those times? Unless you had some record, something handed down from people we can't even identify now, showing what the heavens looked like before Mesopotamia was even a thing. One MUL.APIN section really sticks out. It lists the risings and settings of 36 stars and constellations to mark the year, breaking the calendar into neat pieces. But here's the kicker. Some of these stars can't even be seen from Mesopotamia. The way they're listed, it looks like someone observed them from farther south, maybe somewhere near the Horn of Africa, maybe the southern Arabian coast. Why would Mesopotamian astronomers care about stars they couldn't see? Were they taking notes from travelers or merchants who'd been south and brought back sky stories? Or were they copying from even older sources, from a time before their people settled in Mesopotamia, holding on to knowledge from ancestors or strangers who watched the night from other lands? Then there's the part about planetary omens, where everything gets even more fascinating. These omens, based on the 5 visible planets, Mercury, Venus, Mars, Jupiter, Saturn, were a huge deal. Kings wouldn't make a big move without checking with their astronomers. Temple priests kept an eye on the sky for any hint of what the gods were thinking. Knowing where the planets would be wasn't just handy, it was vital. Politics and religion both depended on it. But here's what really blows my mind. MUL.APIN's planetary tables are way more precise than you'd expect if they were just eyeballing things. The tablets list synodic periods, the time it takes for a planet to return to the same spot relative to the Sun. For Venus, they say 584 days, our modern number, 583.92. For Mars, MUL.APIN has 780 days, modern calculations say 779.94. Jupiter gets 399 days in the text, 398.88 today. These aren't random guesses. They're averages honed over lots of cycles. Venus doesn't hit exactly 584 days every time because the real world is messy. To nail that average, you'd need to watch Venus for hundreds of cycles, tracking it for decades or even centuries, and then crunch the numbers. Mars and Jupiter take even longer. We know the Babylonians were meticulous. They kept records for generations. Temple archives held tablets going back centuries, so scribes could compare notes with people long dead and refine their predictions as new data came in. But even so, the accuracy in MUL.APIN hints at an even deeper tradition, one that stretches back further than we can prove with the stuff we've dug up. How many centuries of watching the sky does it take before you can shave those numbers down to fractions of a day? How many generations of scribes, all dedicated to tracking, calculating, preserving the movements of planets? And who started it? Who was the first to decide, thousands of years ago, that it was worth all this effort to keep such careful watch on the stars? One part of the tablets talks about this thing they call the Great Year. You see it in several Mesopotamian texts, but no one ever really spells out what it means. From the way they use the term, it's clearly a big deal, like some cosmic clock, a stretch of time so long that the stars and planets eventually return to where they started, resetting the heavens. The Greeks picked up the idea later on and called it the Platonic year, or the perfect year. They try to pin it down as the time it takes for every planet to loop back to its starting position, all lined up the way they were before. Figuring that out isn't easy. You need to know the orbital periods of all the planets and find the least common multiple, a number that tells you when all their cycles overlap. It's tricky enough with just the 5 planets you can see with the naked eye. But the Mesopotamians included the sun and moon too, which makes the math almost impossible without modern computers. Yet, in Sumerian and Babylonian texts, the Great Year pops up like it's basic knowledge, just part of how they thought about time and the cosmos. Some researchers say the Great Year is actually the precession of the equinoxes, a 25,920-year cycle caused by Earth's slow wobble, shifting the stars' positions little by little through the zodiac. The Babylonians might have figured that out by comparing star charts separated by centuries and noticing the slow drift. But then again, other clues suggest the Great Year meant something bigger, maybe a cycle involving the planets themselves, not just the stars. We're talking about a span so huge that even seeing part of it would need records stretching over thousands of years. Here, where it gets weird, the number tied to the Great Year in these texts is 432,000, not necessarily years, just units. This number pops up all over Sumerian and Babylonian math and mythology. 432,000 is 120 times 3,600. That's a SAR, a number based on the 3,600-year cycle Sitchin called Nibiru's orbit. Whether or not Nibiru means anything, 432,000 really matters in astronomy. It's about 1/10 of the precession cycle. It's also close to the timing of certain planetary resonance patterns, the kind of repeating cosmic dance the planets do when their orbits sync up in stable patterns. Modern astronomers know this isn't just ancient guesswork. Planets don't just float around at random. Their gravity pulls and tugs, setting up rhythms and relationships that keep everything from crashing together. Take Jupiter and Saturn. They follow a 5-2 resonance. Jupiter loops the Sun 5 times while Saturn does too, and every 7,000 years or so, they end up back in the same part of the sky together. If you try to calculate these kinds of cycles for all the planets, you get periods that last hundreds of thousands of years. There's no way ancient astronomers could have noticed these patterns just by watching the skies for a few generations. Either they had access to records far older than their own civilization, or maybe they inherited some serious math from people who understood orbits way better than we give them credit for. The MUL.APIN tablets never say where this information came from. They just lay it out neat and bureaucratic like everything else Mesopotamian scribes recorded. Grain tallies, royal decrees, whatever. Just lists, numbers, calculations. No explanations, no arguments. Here, what you need. Here, how to use it. That's how they passed knowledge down, not with essays or theories, but with practical manuals. And you know what? It worked. For over 2,000 years, astronomers in Mesopotamia used the MUL.APIN tables to predict eclipses, track planets, build calendars, and advise kings. The predictions held up. The tables kept getting copied, translated from Sumerian to Akkadian, Akkadian to Aramaic. The knowledge survived because it worked, because it was useful, checkable, true. But nobody seems to have asked, or at least no surviving text ever tells us, who wrote the first MUL.APIN? Who actually made those first observations? Who ran the numbers and decided this was worth saving for the future? The tablets don't give humans much credit. They say the gods handed down this knowledge, especially E, also called Enki, the god of wisdom, water, and secrets. In their world, Enki held the ME, these core truths or laws that basically kept reality running. One of those ME was Nam-MULSIDI, knowledge of the stars. It wasn't just stargazing either. This was the actual blueprint for reading the sky, a kind of cosmic manual. The MUL.APIN texts never say, "We figured this out." They say, "The gods showed us." Enki picked certain priests, passed the wisdom to them, and those guys kept it safe in temple libraries and taught it in scribal schools. Now, scholars today usually chalk this up to myth, just the old habit of pinning anything important on the gods so people would take it seriously and remember it. But what if there's more to it? Maybe Enki isn't just a supernatural character, but a symbol for knowledge that came from somewhere else, something humans didn't invent on their own. What if Nam-MULSIDI, the knowledge of the stars, wasn't discovered bit by bit, but handed down, taught directly, given as a gift instead of earned after centuries of sky watching? Look close and you'll notice a pattern in these old texts. It hides in plain sight because it shows up everywhere. When the scribes talk about science or technology, they don't say we invented or our ancestors figured out. They use the passive voice every time. It was given. It was shown. It was revealed. The plow given, writing, revealed, timekeeping, shown to them. Enki taught astronomy. Ninasina gave medical knowledge. The great gods handed down architecture. Everything is an inheritance, not a new achievement. Even kings, when they brag about building temples or digging canals, describe themselves as following ancient instructions, restoring lost things, rebuilding what already existed. The idea of coming up with something brand new just isn't there. For them, everything is about bringing back what's been forgotten, not inventing from scratch. And that leaves a big, silent question echoing in those dusty archives. If the Mesopotamians really inherited their knowledge of the stars, if the MUL.APIN tablets are just the latest copy of something much older, who were the first astronomers? Who watched the heavens in some southern land before Sumer even existed? Who calculated the movements of planets across ages, long before anyone wrote it down? Who understood things like precession or orbital resonance and thought, yeah, this is worth saving, no matter what. Look up at the night sky over Iraq, and you're staring at the same stars the ancient MUL.APIN tablets described. The constellations drift a little thanks to precession, but they're still there, familiar patterns, their names echoing in dead languages that survived only because Greek and Roman scholars bothered to copy them down. The bull still charges ahead of the sunrise in spring. The lion owns the summer. The scorpion lurks as autumn creeps in. These names go straight back to Sumerian priests, 4,000 years ago, chanting under the sky when people still believed the gods walked beside them. At least, that's what the old stories say. So what did those priests actually see when they looked up? Were those stars just pretty, distant lights, random and mysterious? Or did those old astronomers spot something we're only now starting to grasp? Coordinates, signposts, a bigger map we've missed for centuries. Maybe they recognized patterns we needed telescopes and supercomputers to confirm. Maybe in their own way they mapped the solar system, long before Voyager snapped that famous photo of Earth hanging like a speck in space. Today, the MUL.APIN tablets sit in archives. Researchers translate them, check their context, dissect their cultural meaning. But almost nobody asks the obvious thing. Not just, what do the tablets say? But how did they even know? How did people with nothing but sharp eyes, sighting rods, and water clocks gather data so accurate that modern astronomers back it up with satellites and software? That's not luck. Precision comes from generations watching, sure, but it doesn't give you the big picture. You can track where the planets go, but you don't get the why unless you have a model, some idea of orbits, heliocentrism, gravity. But the Babylonians had that model. Their calculations in MUL.APIN show it, plain as day. They predicted planetary movements with math that only really makes sense if you know planets orbit the sun, Earth included, and that those orbits create all the weird stuff like retrograde motion. They knew. They figured it out thousands of years before Copernicus got in trouble for saying the same thing, before Galileo was forced to back down, before Kepler spent his life working out the math. The Babylonians just wrote it down as fact. This question just keeps coming back, doesn't it? How did they know? And the answer, the one that shows up right there in the ancient texts, the one we're all taught to brush off as nothing but myth, is actually pretty clear and honestly a bit unsettling. Someone taught them, the Anunnaki, beings who, according to these stories, came down from the sky, crossed the vast distances of space, and already understood the solar system because they'd seen it from the outside, from up there. From a place no human would glimpse until rockets and satellites made it possible. Now, let's say VA-243 really is a map. Let's say MUL.APIN is more than just a list, but a kind of legacy. If all that sharp astronomical detail in these old Mesopotamian writings comes from knowledge handed down, not stumbled upon, then you have to ask, what else did the Anunnaki teach? What's still hiding in those so-called myths? Stuff we've waved off for centuries just because we figured ancient people couldn't possibly know it. Turns out, some of it only looks impossible, until modern science catches up and suddenly, the old stories start sounding less like fairy tale-ese and more like eyewitness reports. Down in those quiet museum basements, where VA-243 sits behind glass, and in the climate-controlled vaults that guard the MUL.APIN tablets, the pieces are all there. They've been there a long time. Most of them probably won't ever get put together. Researchers tend to dive so deep into their own specialties, translating one text, dissecting one artifact, publishing papers that maybe a dozen people in the world will actually read. Not many folks take a step back to look at the big picture, to see that all these oddities, these so-called mistakes and weird coincidences, actually fit together. They hint at something bigger, something that says the Sumerians and Babylonians knew things they absolutely shouldn't have known, something that points to a source we've trained ourselves to ignore. But the stars don't care what we believe. They keep moving same as ever. Following the math the Babylonians worked out, the patterns etched into MUL.APIN, the shapes VA-243 might have been trying to capture. And if we can just be patient, if we can look at what's in front of us without all the baggage, maybe the stars will give us a clue. Maybe we'll figure out where this knowledge actually came from, where the Anunnaki came from. Maybe we'll even spot the trail they left, still waiting in stone and clay, hidden in the dark, hopping, we'll finally realize what's right in front of us. Let's talk about the artifact that quietly rattled some nerves when scholars first took a good look at it. I mean, it's just a small clay tablet from Sippar, barely 4 inches, nothing flashy, sitting in the Iraq Museum with the label IM 67891. They say it's from around 1800 BCE. At first glance, it looks like your standard bit of ancient astronomy, predictions for lunar eclipses, all based on the Saros cycle. Nothing out of the ordinary. But then, tucked away in the margin, the scribe left a tiny diagram. Not just decoration, a circle for the moon, sandwiched between 2 bigger circles, Sun and Earth. The drawing lines them up dead center. That's the setup you need for a lunar eclipse, with Earth's shadow covering the moon. Here's the wild part. This isn't geocentrism. This scribe saw the moon as an object circling Earth, and both of them as part of a bigger system that dances with the sun's light to make eclipses happen. They drew Earth and moon as separate things in space, almost as if they'd stepped outside the whole setup and were watching it play out from the outside. You can't really draw that unless you get the idea, unless you know there's an outside perspective at all. How do you show 3 bodies lining up unless you picture them as real objects in space, not just lights moving around on a dome above your head? Back in 1952, someone published this tablet in an academic journal. They called the diagram unusual imagery, then moved on. No deep dive, no follow-up. It didn't fit the tidy story of slow, step-by-step progress in astronomy, so it just got cataloged and forgotten. Yet the tablet is real. Or was anyway. It lived in Baghdad before the 2003 looting of the Iraq Museum, and who knows where it is now. But the photos, still here. The diagram, still here. And the question still nags. Then there's another artifact that popped up in the 1970s at Uruk. This time it's a stone tablet, cracked and broken, with writing that describes the distances between celestial bodies. The units are a headache, translated as leagues, but that term shifted all over the place, so converting to modern units is a mess. Still, the ratios between the distances survived. The tablet lists the gap from the first heaven to the second to the third, all the way through 7 heavens, with each space spelled out. When researchers crunched the numbers, the ratios looked familiar. They almost matched the spacing between the planets in our solar system. If you look at the distances between the planets and the Sun, Mercury, Venus, Earth, and so on, you'll notice a kind of pattern. There's actually a formula for it, the Tish's-Bode law. It's not perfect, but it predicts where the planets are with weird accuracy, even though nobody really knows why. Scientists came up with it in the 18th century, and honestly, they couldn't explain how it worked. It just did. When Uranus showed up in 1781, it fit the pattern too. Now, if you check out the Uruk tablet, the numbers don't line up exactly with Tish's-Bode, but they're close enough to make you wonder. Whoever made that tablet didn't just see planets as random dots in the sky. There's this sense they understood the planets are spaced out in a kind of regular mathematical way. But how would an ancient scribe even know that? It's not enough to just map where planets appear. You'd have to figure out their actual distances from the Sun. That's tough. You need parallax measurements or something similar, and nobody pulled that off until the Renaissance. So, what gives? Maybe someone told them. Someone who knew the real layout of the solar system, like actually traveled those distances and saw it firsthand. You see hints of this in the texts themselves, almost like it was no big deal. Take the Enuma Elish. When it talks about Marduk organizing the heavens, it says, "He fixed the positions of the great gods, the stars their likenesses, he made them shine. He set the year, marked off its divisions, and for the 12 months he appointed 3 stars apiece." That's zodiacal astronomy, dividing the calendar by constellations, pretty standard for Mesopotamia. But then it goes further. It describes Marduk measuring the Apsu, the deep, and laying out the heavens, fixing the planets in their orbits, setting their paths according to the pattern of the original design. That's not just poetic language. When you see words like pattern and design, it feels like they're talking about an intentional blueprint, not just a random mess. An original design that hints at something pre-existing, a template Marduk followed instead of making things up as he went. If someone designed the solar system, if its structure actually follows a plan, then looking at it isn't really discovery. It's more like archaeology, digging up blueprints left behind by whoever built it in the first place. That's basically how the Mesopotamians saw astronomy. They weren't out there hunting for unknown mysteries. They thought they were revealing a structure that was already set, just waiting to be uncovered. You see this attitude show up in the Epic of Gilgamesh, too. There's that wild scene where Gilgamesh and Enkidu walk through the tunnel of the sun. The details are weirdly precise. They travel 12 leagues in pitch darkness before they start to see light again. The text doesn't just gloss over it, either. It really leans into the experience of moving through this tunnel, finally coming out into the Garden of the Gods, a place where everything's made of jewels, where the trees have lapis leaves and carnelian fruit. Classic ancient myth stuff, sure, except for those 12 leagues of darkness. That's oddly specific, 12 units of distance spent in total darkness, and only then do they step into the light. Some scholars say this is just a symbolic trip through the underworld, a metaphor for dying and coming back to life. But the details don't quite fit. Why exactly 12 leagues? Why make such a big deal about the gradual change from darkness to light? If the tunnel stands for the sun's path under the earth at night, traveling from sunset to sunrise, then maybe those 12 leagues are the 12 hours of night. But the story really focuses on moving through space, not time. It's about covering ground, not counting the hours. And when they finally get to the Garden of the Gods, it doesn't really sound like metaphor. The text describes it like it's a real place, a destination at the end of a long, dark journey, somewhere the gods actually live. So what if the tunnel of the sun isn't just a symbol? What if it's describing something else? A journey through space itself, across the solar system, leaving Earth and crossing the dark until reaching a place lit by starlight, a home for the Anunnaki, their garden, their outpost. Admittedly, this is a stretch, way too literal for most scholars, who are trained to read all this as pure myth. But those details keep showing up, stubbornly specific in a way that feels odd for pure invention. Then there's the Era epic. In that story, the god Era stirs things up and throws the universe out of balance. The bonds of heaven and earth get loose. Everything goes haywire. The positions of the celestial bodies were altered. The pathways of the stars were changed. Only when Marduk steps in does order return. He restores the original configuration and puts the heavens back on track. This sounds a lot like someone describing orbital perturbation, when a massive object swings through the solar system and throws everything off balance. Planets get nudged, their paths change, and it takes a long time for things to settle back down. You get the sense that whoever wrote this actually saw something like it happen, but only had myth and legend to explain what they witnessed. So they blamed it on gods fighting in the sky. But at the core, they're really describing planets shifting, orbits thrown off, the whole cosmos in need of repair. Modern astronomy knows this stuff is real. When a rogue planet or a big asteroid comes close, its gravity messes with everything nearby. Orbits move, old patterns break, and the solar system goes through a rough patch before gravity slowly pulls things back together, sometimes into a whole new setup. The early solar system got hit by this over and over. Take the late heavy bombardment, for example, about 4 billion years ago. Back then, the inner planets got bombarded by waves of asteroids and comets. Scientists think Jupiter and Saturn moved around and shook up the asteroid belt, sending debris flying everywhere. We have solid evidence for this, crater counts on the moon, what we find in ancient meteorites, computer models showing how planets and rocks dance around each other. It's not a fringe theory. This is mainstream science. But all that happened ages before people showed up. Unless, of course, the Era epic actually remembers something more recent. Maybe, just maybe, a massive object really did pass through the inner solar system while humans were watching. It could have thrown off the orbits, triggered chaos on Earth, tidal waves, earthquakes, storms, and then vanished, leaving only stories of gods warring and the heavens in turmoil, with Marduk stepping in to fix things. So was that object Nibiru? If Nibiru is real, and it follows the wild orbit Sitchin talked about, a huge loop through the solar system every 3,600 years, then a close pass would shake up Earth's orbit tilt, even its spin. The fallout would be brutal. We're talking earthquakes, volcanoes, tsunamis, wild climate swings. Basically, all the disasters ancient Mesopotamian texts mention when they describe divine punishment: earth quaking, skies going dark, floods sweeping the land. Mainstream astronomy just doesn't buy it. There's no sign of any recent shakeup in the inner solar system. Earth's orbit, steady as ever, and all the evidence, geology, astronomy, you name it, backs that up for millions of years. If some rogue planet had swung by close enough to mess with Earth's path, we'd see it. It would show up somewhere: tree rings, ice cores, layers of sediment. But if you go looking, you find nothing. No planet Nibiru, no smoking gun. So people chalk up the era epic as myth, not history. The stories about shifting stars and planets, just metaphor, not a record of real events. But honestly, just because we don't see something doesn't mean it didn't happen, especially when the signs might be subtle, scattered, or just plain misunderstood. Tiny changes, like a barely there nudge to Earth's axis, aren't going to leave glaring marks. They might show up as odd weather, floods, earthquakes that get filed away as business as usual, not as the aftermath of some cosmic close call. And if the last flyby happened 3,600 years ago, around 1600 BCE, the evidence would be buried deep, tangled up with all the chaos of the Bronze Age, mixed with human fingerprints, hard to pick apart from the noise. The 17th century BCE was a wild time anyway. Thera blew its top and wrecked the Minoans. Tree rings from halfway around the world pick up weird climate blips. The Indus Valley civilization collapsed. Egypt's Middle Kingdom fell. The Hyksos swept into the Levant. All these societies all at once facing disaster, not from wars or internal strife, but from the environment turning against them. Crops failed, trade failed, people moved. Was Nibiru behind it? Did its gravity tip the balance, spark volcanoes, mess with the weather, set off the dominoes that toppled those ancient worlds? It sounds like a stretch. Mainstream science won't touch it. Too many leaps, too little proof. Still, the timing lines up in a way that's hard to ignore. And those old Mesopotamian texts, right from that era, they talk about chaos among the gods, the sky in disarray, Marduk stepping in to fix things and bring back order. Is that just a story, or is it memory, preserved in myth because that's all they had? Deep in the archives, tucked away in the cold quiet of museums and university libraries, the clay tablets just sit there. They don't offer any extra answers. They just exist, inscribed, silent, waiting for someone to wonder if the old myths actually hold observations, if religious texts might hide bits of astronomical data, if stories about gods are really people trying to describe things they saw but couldn't explain with science. The Anunnaki supposedly dropped down from the sky. They came from Nibiru, crossed the empty miles of space, swung through our solar system when their planet drifted close, landed on Earth for a while, then left again as Nibiru drifted back out. They left behind stories, maybe some knowledge and technology, their memory pressed into tablets that somehow survived thousands of years. That's the story Sitchin pieced together from the Sumerian and Akkadian texts. Mainstream scholars don't buy it. They say the facts just don't support a literal reading. Myth, not history. The astronomy is all symbolism, not observation. The Anunnaki are gods, not visitors from space. Nibiru, just a made-up planet invented to fill in the blanks. But the questions pile up. How did the Sumerians know so much about the sky? Their texts describe the solar system in ways that fit discoveries we only made with satellites and telescopes. Some cylinder seals even seem to show diagrams with more planets than anyone back then could see. MUL.APIN lists star positions from ages before people even wrote things down. Some old fragments nail the distances between planets, numbers we didn't calculate until the 1700s. Academia usually chalks it up to coincidence, lucky guesses, misunderstandings, or ancient symbolism mistaken for scientific description. And maybe they're right. Maybe the Mesopotamians just happened to create myths that matched reality without any way of actually knowing. Maybe VA-243 is just a religious symbol that accidentally looks like a solar system. Maybe MUL.APIN's accuracy comes from centuries of careful skywatching by astronomers whose earlier work is just lost. Maybe the stories about shifting stars are just poetic flourishes. Maybe those distance ratios are copyists' mistakes, or just ancient numerology with no connection to the real solar system. Maybe every weird detail has a simple explanation, and the patterns we think we see are just our minds reaching for meaning in a world that's mostly chaos. Maybe the Sumerians really were telling the truth. Maybe the Anunnaki actually existed. Maybe they came from somewhere far out there, a planet on a long, looping path that takes it through the outer solar system and sometimes brings it close enough for travel between worlds. Maybe they looked up and mapped the stars from their own unique point of view, and then passed those maps to humans, who pressed them into clay, carved them in stone, copied them again and again over centuries. What if that old tablet, VA-243, is just what it looks like? A diagram of the solar system as seen by people who could see the whole thing laid out. Maybe the knowledge on those tablets wasn't invented, or guessed, or even stumbled upon. Maybe someone just handed it over. If that's true, the real question isn't how the Sumerians knew. It's what else they were told. What else did they save for us, tucked away in texts we keep misreading, just because we're sure the answers have to fit inside the neat little boxes we've built for ourselves? Boxes that leave no room for teachers from the stars, or for knowledge passed down from worlds beyond ours, or for maps etched in clay by people who knew exactly where those visitors came from, and wanted us to know too. The stars still spin overhead, the same patterns the Sumerians once named, the same cycles they tracked, the same cosmic shapes they honored and feared and studied for centuries on end. And somewhere out there, maybe, a planet still moves along its stretched-out orbit, gliding through the darkness, and then swinging close to the sun every few thousand years. It carries with it the memory of beings who came to Earth when everything was new, who taught and built and then left, leaving behind only stories. Stories we've called myths for so long that we've forgotten they might be history. In the silence of museums, in the dim light of storage rooms, behind heavy doors and climate controls that keep ancient clay from crumbling to dust, the evidence just waits. Not proof, not certainty. Just enough weirdness, enough little details, enough accuracy showing up where you'd never expect it, to make you stop and wonder. What if the Anunnaki were real? What if they came from a planet we're still looking for? What if the Sumerians actually recorded its orbit, sketched its path through the solar system, and pressed it all into tablets small enough to fit in your hand, tough enough to outlast whole civilizations? What if we've been staring at the answer all along, writing it off as decoration, labeling it as religious art, stacking it in basements while the truth sits in plain sight, pressed into clay by hands that remembered, that tried to warn us before everything slipped away, before the knowledge vanished like it always does, when the gods leave and people are left alone to wonder what their ancestors once knew and what, somehow, we lost. Cylinder seals and clay tablets aren't the only maps the Anunnaki might have left behind. If they really existed, if they landed here with the kind of astronomical knowledge those old texts hint at, they wouldn't have just scribbled coordinates or drawn star diagrams in clay. They'd need something that could outlast time itself, something bigger, something you notice even if you couldn't read a word of their language, permanent markers, monuments. Look around the ancient world. Egypt, Central America, the British Isles, Easter Island. Massive stone structures perfectly aligned with the stars, built with a precision that still baffles us today. These places aren't covered in signatures. Most of them were already ancient when the earliest written histories came along. But they share traits, a kind of cosmic obsession, an understanding of the sky written in stone. When you really start measuring, mapping, and comparing their alignments, you keep running into the same story. A grasp of the solar system, a talent for tracking stars, a drive to lock that knowledge into something that would never fade away. Take the Great Pyramid of Giza. People have studied it more than any other building on Earth, and it still refuses to give up all its secrets. Mainstream history says it went up around 2560 BCE during Khufu's reign. 2.3 million stone blocks moved into place, some weighing more than 80 tons. They fit together so tightly you can't even slip a razor blade between them. And the alignment. The pyramid faces true north with an error of just 3/60 of a single degree. Not magnetic north, true north. You need to watch the stars and do some serious math to pull that off. Today, surveyors spend years learning how to align buildings that accurately, and they use modern tools. The Egyptians did it with gear we can barely recognize, and nobody in the West matched that precision until the Renaissance. And that's just the alignment. The pyramid's proportions hide weird little math secrets. The ratio of its perimeter to height is exactly 2 pi, the same relationship as a circle's circumference to its radius. In other words, the pyramid is a scale model of the northern hemisphere. Height, that's the radius from Earth's center to the pole. Perimeter, that's the equator. Whether the builders meant to do this or just got lucky, the numbers speak for themselves. Then there's the golden ratio phi, about 1.618, that pops up in the pyramid's design. You see phi in nature, in galaxies, sunflowers, even in the human body. Mathematicians didn't even write about it until Euclid, 2,000 years after the pyramid went up. But there it is, built into the stones. Inside, the king's chamber sits deep in the heart of the pyramid, put together from gigantic granite blocks hauled all the way from quarries 500 miles away. Its shape isn't random. The chamber's volume is exactly half what it would be if you doubled its height, a double cube, a shape known for its harmonic and acoustic qualities. And get this, the chamber's natural resonant frequency is 7.83 Hz, the same as Earth's own electromagnetic pulse, the Schumann resonance. Scientists talk about that frequency when they study how the planet hums, and it even pops up in research on meditation and biological rhythms. The Egyptians didn't know about electromagnetic fields, at least as far as we can tell, but they built a room that resonates in perfect tune with the planet. Was that just luck, or did they know something we've only started to figure out? There's something strange about the pyramid's alignments with the stars. Those 4 narrow shafts, the ones leading from the king's and queen's chambers, don't actually break through to the outside, like you'd expect from ventilation shafts. Instead, they angle up with almost eerie precision, lining up with specific stars as they appeared in the sky around 2450 BCE. The southern shaft from the king's chamber points straight at Alnitak, the brightest star in Orion's belt. The northern one aims at Alpha Draconis, which was the pole star back then. Over in the queen's chamber, the shafts point to Sirius and Beta Ursa Minor. None of these stars are random. Orion stood for Osiris, god of death and rebirth. Sirius was tied to Isis, Osiris's sister and wife. The shafts basically form a bridge, both symbolic and literal, between the pharaoh's resting place and the heavens, the very realm of the gods. But there's more to it than symbolism. These shafts are so accurately aligned, they work like ancient astronomical tools. You could use them to track the positions of the stars at certain times and over centuries, even follow the slow drift of the equinoxes. That's not just a fancy tomb. That's an observatory, a cosmic timekeeper. The builders locked astronomical knowledge into stone in a way so massive and exact that it couldn't be copied without real understanding. And here's the kicker. The Egyptians never actually claimed to have designed it. The oldest Egyptian records that mention the pyramid already treat it as ancient, the work of gods or some earlier people with knowledge beyond anything the pharaohs knew. Take the inventory stela, found near the pyramid in the 1800s. The inscription, said to be from Khufu himself, claims he restored the pyramid and the Sphinx, not that he built them. He found them damaged, fixed them up, and rededicated them. Egyptologists called the stela a forgery because it didn't fit their timeline, but nobody's ever proved it's fake. It exists, plain as day, sitting there and poking holes in the story that Khufu was the original builder. So if the pyramid really predates Khufu, if it was built by some earlier, more advanced civilization, then who did it? And what did they know about math, the stars, even the Earth's own resonance that let them encode all of that into a monument that's outlasted every other empire? On the other side of the world, deep in the jungles of Central America, you'll find structures just as precise as the pyramids of Egypt. The Mayan pyramids at Tikal, Chichen Itza, and Palenque line up with the sun and stars in ways that honestly seem impossible without some serious math and careful sky watching. Take the Pyramid of Kukulkan at Chichen Itza. People say it went up around 1000 CE. During the spring and autumn equinoxes, if you stand by the northern staircase in the afternoon, you'll see shadows snake down the steps, literally forming the shape of a serpent sliding from the top to the ground. It only happens twice a year, just for a few hours each time. For that effect to work, the Maya had to nail the orientation, the angles, and even the placement of decorations. They had to know exactly how the sun would move through the sky in that spot, on those exact days. They weren't just guessing. The Maya understood the sun's path, how shadows would fall, and they planned out the whole spectacle on purpose. Their pyramid became a calendar and a lesson in astronomy all in one. But where did they get this knowledge? The Maya didn't have written contact with Egypt. No trade routes connected them to Mesopotamia. Still, when you look at their old books, the Dresden Codex, the Madrid Codex, you find calculations for Venus's cycles, predictions for lunar eclipses, and solar year measurements that match the Babylonians. They tracked Venus obsessively, nodding when it appeared, vanished, looped backward, and how its cycles lined up with Earth and the Sun. The Dresden Codex nails Venus's synodic period at 583.92 days. That's accurate within a few hours of today's measurements. Basically the same precision you see in Mesopotamian records written thousands of years earlier, half a world away. So how did both civilizations get the same results? The simple answer is that both watched the sky, kept records for generations, and did the math until their numbers lined up with reality. Sure, that works, but the level of precision hints at something deeper, actual mathematical models, maybe even a grasp of planetary mechanics, not just years and years of checking off days on a calendar. And here's the weird part. Both the Maya and the Babylonians say they didn't come up with this knowledge themselves. The Maya say Kukulkan, the feathered serpent from the sky, gave them their calendar and astronomy. The Babylonians point to or Enki and the Anunnaki. Different names, but the same kind of story, knowledge handed down by gods, not invented by humans. Teachers from the heavens, knowledge as a gift, not a discovery. Now let's talk about Stonehenge, a giant ring of stone set out on Salisbury Plain in England, built in different phases between 3000 and 2000 BCE. Some of those stones are just massive, over 25 tons each, and people dragged them from quarries more than 150 miles away. What's wild is how precisely they arranged everything. Stand in the center during the summer solstice, and you'll see the sun rise right over the heel stone. Not just close, but within a hair's breadth of perfect alignment. That kind of accuracy means they had to really understand the sun's yearly path, figure out exactly where it would rise on the solstice, and then set up these stones so the whole thing would work. But Stonehenge isn't just about the sun. Researchers have found that the layout also lines up with the moon's extremes, the lunar standstills that come around every 18.6 years. This suggests they weren't just celebrating the solstice. They were tracking the moon's movements and maybe even predicting eclipses. Around the main circle, there's this ring of 56 pits called the Aubrey Holes. Some think they used these as a sort of giant calendar, marking the moon's position and using the pattern, pretty much the same 18-year Saros cycle the Babylonians used, to forecast eclipses. Now here's what really gets me. These were Neolithic people, no writing, no cities, none of the stuff we usually link with advanced science. Yet somehow they dug exactly 56 holes, a number that doesn't seem practical unless you're doing some serious calculations about the moon and eclipses. People usually say, sure, it was all trial and error, generations watching the sky, spotting patterns without really knowing the theory behind them. But building something like Stonehenge needed huge resources, a ridiculous amount of coordination, and planning that spanned lifetimes. Someone had to know before they even started that the design would actually work, that the alignments would line up, and that the whole system would do what they needed. But the builders left nothing behind to explain how they figured it out. No texts, no carvings, just these stones, set up with a precision that makes you wonder if they really couldn't have known what they were doing. Unless someone taught them. Maybe the knowledge came from somewhere else, passed down by people who'd already mastered the sky, who could map out alignments because they'd seen the solar system from a different perspective. Maybe that's why we see similar monuments all over the world, massive structures, lined up with the heavens, built with math and engineering that feels too advanced for the time. Too many similarities to just brush off as coincidence. Stories everywhere blame gods or giants or ancestors with lost wisdom for these wonders. And honestly, you start to see why. On Easter Island, those Moai statues stand with their backs to the ocean, staring toward the heart of the island. They're not just scattered around at random, either. They show up at places that line up with the solstices and equinoxes. The Rapa Nui carved nearly 900 of these giants. Some are taller than a 3-story building and weigh as much as a small airplane, yet they somehow managed to move them across the island without wheels or animals, using methods we still can't quite figure out. Why do the statues face inward? It looks like they were marking something, maybe tracking the sun, maybe keeping an eye on the stars. Setting those things up right takes more than just an eye for detail. You need to know where the sun rises and sets on certain days, how to position these massive stones so they line up just right. It's the sort of thing you wouldn't expect from a small, isolated group, but they did it. Then there's Peru, where the Nazca lines cut through the desert, huge shapes and animals you can only really see from way up above. Some of these lines go on for miles, perfectly straight, ignoring hills and dips in the ground like they don't even matter. People say some of them point to where the sun, moon, or certain stars rise or set on special dates. The Nazca made these between 500 BCE and 500 CE, long before anyone flew over them in an airplane. So who were they for? Who was meant to see them? A basic calendar doesn't need lines you can only see from the sky. It took a huge effort to make these designs, and for what? Some think the lines were messages, signals for someone flying overhead. The Nazca even believed their ancestors could fly, that the gods came down from the sky to teach them. You hear the same stories with the Maya, the Sumerians, the Egyptians, pretty much every ancient civilization that built big, star-aligned monuments. Cultures separated by oceans and centuries, all building things that need serious math, astronomy, and engineering knowledge. Every one of them says the same thing. The gods came from above, taught us, built with us, then left, but not before promising to return. We call these stories myths because the alternative just feels too strange. If we take them at face value, it means humans didn't figure everything out on their own. Maybe someone gave us a push, someone who already knew their way around the stars, who could build things we're only just starting to understand, who could calculate orbits and distances across the solar system because that was just part of their everyday life. Imagine for a second that those ancient teachers were real. Let's say the Anunnaki actually existed. They came from some distant planet, way out in the solar system, and every so often, their world swung close to Earth. Suddenly, all these old monuments start to make sense. They're not just piles of rock or temples for rituals. They're markers, waypoints, giant instruments set in stone, and built to last longer than any language or story we could ever write down. They're mapped out for the stars, not for the ground. These ancient builders aimed them at the sky, at constellations and planets, tying them to the slow drift of the stars over centuries. They locked real knowledge into stone, so permanent it outlives memory. Standing at Stonehenge at dawn, or in the cool shadow of the Great Pyramid at noon, or deep in the jungle where Mayan pyramids break through the trees, or out in the desert where Nazca lines stretch on and on, these places just wait. Quiet, patient, still lined up with the same stars, marking the same spots night after night, year after year. They hold information we've trained ourselves to ignore. We call it coincidence, luck, myth. Because if we admitted what these monuments really are, we'd have to rewrite everything. Our whole story about where we came from, who we are, whether anyone ever really walked beside us from somewhere else. What if, a long time ago, teachers really did come from the stars? What if they built in stone so their lessons would survive? And then, when it was time, they left, and all we had left were these monuments and stories we started calling myths. But maybe they're not just stories. Maybe they're memories. The monuments don't say a word. They don't need to. They just stand there, lined up with mathematical precision, encoded with secrets, waiting for us to finally notice what they've been pointing to all along. We were taught. The knowledge came from the stars. The maps, carved in clay and raised in stone, lead to places we haven't explored yet, planets we haven't found, maybe even a home world that drifts in the darkness beyond Neptune, only coming close enough every few thousand years. Close enough for the Anunnaki to visit, to teach, to build, to leave behind clues we keep finding but never really understand. And what if that old VA-243 tablet isn't just a religious symbol? What if it's a snapshot, someone's memory of the solar system from above? Someone who traveled between worlds, who'd counted the planets on the way in. What if MUL.APIN is more than myth? What if it's a set of star charts, real navigation data, meant to guide a ship through the solar system, coded into clay because it was the only way to make sure it lasted until the next visit? What if those ancient monuments aren't just religious relics but landing sites or cosmic markers, built huge so they'd last for millennia, lined up with stars that hardly budge, even as the Earth wobbles through the ages? Maybe they're giant signposts for travelers who come back every few thousand years, not just once in a human lifetime. The more you dig into this idea, the more questions pile up. Every answer leads to another mystery. Every new theory stretches the limits of what we think we know about ancient history, about how civilization started, about what humans were really capable of. But the evidence just sits there, no matter how much it rattles our assumptions. The tablets are still around, carved with accuracy you can't get with the naked eye. The monuments still stand, lined up so precisely you'd need real astronomical knowledge to pull it off. The old texts don't shy away from wild claims. Beings descending from the sky, epic journeys across the stars, knowledge handed down from visitors above. And in museums, in locked drawers and vaults, the maps wait. The VA-243 tablet behind glass in Berlin, the MUL.APIN star lists tucked away in university collections, cylinder seals engraved with what look like orbital diagrams, labeled and shelved, sometimes studied but never really explained. They're almost too precise, too bold, too much for anyone to deal with comfortably. But they're still there, quietly insisting that maybe we don't have it all figured out, that maybe civilization didn't start the way we like to think, that maybe our ancestors weren't as clueless as we imagine. In some ways, they knew things we're only now starting to rediscover. They built things we can barely copy with modern machines. They wrote down data that we end up confirming with satellites and supercomputers. Their star maps match up with what we see, down to details they supposedly couldn't have figured out, unless someone taught them, unless the Anunnaki really were here. Unless those maps aren't myths, but real coordinates, an address for a planet that still waits out there in the cold, following the orbit the Sumerians tracked, the path Sitchin talked about, all carved into clay 4,500 years ago by people who remembered, people who wanted us to know, before everything faded into silence and the gods left, and all we had were ruins and riddles. And what if the search has already started? What if modern astronomers, with gear the Sumerians couldn't even dream up, are actually finding what the ancient maps showed? Out past Neptune, in the frozen Kuiper Belt where sunlight barely reaches and everything's colder than you can imagine, something going on. Objects are moving in ways that don't make sense. Their orbits cluster together, like they're being nudged by something big, something we haven't seen yet. Something maybe carved into clay thousands of years ago and brushed off as legend, until the evidence got too strong to ignore. Back in 2015, NASA's New Horizons zipped past Pluto and sent back photos that blew everyone's minds. Sweeping plains of nitrogen ice, mountains made of frozen water, a heart-shaped patch that got people talking. But as New Horizons kept going, deeper into the Kuiper Belt, its sensors picked up something weird. Small, icy worlds orbiting way out at the edge of the solar system, following paths that weren't random at all. There was a pattern, a kind of order, a clustering that hinted at something else shaping their journeys. Something hidden, still waiting to be found. Dr. Michael Brown and Dr. Konstantin Batygin, both astronomers at Caltech, dove deep into the orbits of these odd trans-Neptunian objects. They didn't just look at the data, they threw thousands of scenarios into computer simulations, matching what they saw through telescopes with what their models predicted. What came out of that work, first published in the Astronomical journal back in 2016 and sharpened in later studies, was hard to ignore. The gravitational fingerprints of a planet about 10 times the mass of Earth, orbiting somewhere between 400 and 800 times farther from the Sun than we are. This planet, Planet Nine, would crawl through a single orbit in 10,000 to 20,000 years. Naturally, the scientific community didn't leap to embrace it. People were cautious, but you could feel the curiosity buzzing. This was no wild Nibiru theory with its 3,600-year orbit. This was something way farther out, much slower, and so faint you never spot it directly. The only way to see it, really, was by watching how it tugged at smaller objects, warping their orbits and leaving behind a pattern you couldn't chalk up to chance. The idea was simple. There's a big planet lurking out there, hidden from direct view, but its influence is written all over the outer solar system. A planet we never expected. A world our textbooks didn't warn us about. A new member of the solar system, just now coming into focus. By 2019, more evidence piled up. Dr. Scott Shepard from the Carnegie Institution for Science found even more distant objects with orbits that just didn't fit the old models. These bodies moved in such strange, clustered paths that, statistically, there's almost no way it happened by accident. The chance these alignments were random dropped below 1%. Something was definitely out there. The hunt picked up speed. Observatories all over the United States, from Hawaii's Subaru telescope to California's Palomar Observatory, joined in, sweeping the skies in infrared, searching for the faint heat signature a far-out planet might give off. The Vera C. Rubin Observatory in Chile, set to start scanning soon, was built partly for this purpose, to photograph the entire sky every few nights, catching anything that moves, anything we might have missed before because our eyes or our instruments weren't sharp enough. But while people chased Planet Nine, the Kuiper Belt kept tossing out surprises that messed with everything we thought we knew about how solar systems form. Out there, objects orbit at ridiculous distances, way past the zone where planets should have had enough material to come together. Some of them, like Sedna, discovered in 2003, run on orbits so stretched out that, at their farthest, they're nearly 1,000 times farther from the Sun than Earth. From Sedna's distant perch, the Sun is just another bright star, barely warming anything, barely holding sway. Sedna takes 11,400 years to make one loop around. Even at its closest, it never gets nearer than 76 astronomical units. That's still out of Neptune's gravitational reach. Something else shaped its path. Something big must have swung by once and flung Sedna onto its strange journey. Then in 2014, astronomers found 2012 VP-113. Its orbit looked a lot like Sedna's, closest approach at 80 astronomical units. One trip around the Sun takes 4,300 years. Two such oddballs with similar orbits. That's a pattern. By 2018, more objects like these turned up, all pointing to something large and distant, hurting these bodies with its gravity. Then, in 2021, came the discovery that broke out of astronomy circles and caught the wider scientific world's attention. Researchers digging through old data from the WISE infrared telescope spotted an object called 2014 FE72. Its orbit never brings it closer than 50 astronomical units, and at its farthest, it drifts out past 1,500 astronomical units, an orbit that takes more than 30,000 years to finish. There's no way to explain that path just with the planets we know. You need something else, something massive, something lurking out in the dark to carve out a route like that. The data went through peer review. Follow-up observations confirmed it. The object is real, moving through the black on a path that makes no sense unless we accept there's another planet out there. The solar system isn't as catalogued and tidy as we thought. There's more out there, more than we've ever seen, more than we used to admit. In 2023, a team at NASA's Jet Propulsion Lab in Pasadena took a close look at Planet Nine. They pulled data from a bunch of observatories and ran orbital simulations. Here's the wild part. If Planet Nine really exists, and it's as big and as far out as people think, its gravity lines up perfectly with those weird clustered orbits we see in trans-Neptunian objects. The models matched up with reality. The predictions actually fit the evidence. It's not proof, not quite, but honestly, the case was getting hard to ignore. Planet Nine moved from wild idea to a real scientific hypothesis, something worth searching for instead of just debating. But that's when the questions shifted. If Planet Nine's out there, where did it even come from? The usual models say it couldn't have formed way out there. There just isn't enough stuff, no real crowd of rocks or dust beyond Neptune to build a planet 10 times the size of Earth. The protoplanetary disk was too thin that far from the Sun. So maybe Planet Nine formed closer in, somewhere between Jupiter and Neptune, and then got kicked out by the big gas giants during the solar system's early chaos. Imagine it, flung into the dark, settling into that distant orbit, shaping the Kuiper Belt and nudging the paths of icy objects, all while staying too far, too cold, too hidden for our telescopes, so far anyway. But then there's another idea. It pops up in research papers now and then, carefully worded, not exactly mainstream but not dismissed either. What if Planet Nine isn't even from around here? Imagine the Sun's early days, still hanging out with other young stars in a cluster. Sometimes those stars drift close and their planets can swap places. Maybe Planet Nine got captured, a wanderer from interstellar space, snagged by the Sun's gravity at just the right moment, with just the right velocity, losing just enough energy to settle in for the long haul. It sounds rare, and it is, but simulations say it can happen. A rogue planet drifting between stars could end up as part of our solar system if the timing's perfect. Let's say Planet Nine really was captured, a wanderer from another star system that the Sun snagged long ago. If that's true, it wouldn't be like the other planets born right here. Its makeup, its insides, even its warmth could all hint at a weird alien birthplace, evidence it formed far away, somewhere else in the galaxy under very different skies. And if it came from outside, if it barreled into the solar system and settled way out in the dark, someone might write, quote, "V seen it." Someone watching the sky, sharp-eyed enough to notice a new heavyweight taking up space at the edge of everything. Maybe it was the Anunnaki, if they were real, if they were here, if they cared enough to keep watch when Planet Nine arrived. Is that too much of a stretch? Maybe. But here we are in 2025. Telescopes keep hunting. Computer models get smarter every year. With every new discovery of distant objects moving in sync, the case for Planet Nine just gets stronger. So maybe we're close, closer than we think, to confirming something the Sumerians claimed to know ages ago. That our solar system holds more planets than anyone standing on Earth could ever guess. That to really understand our own neighborhood, we have to look past the obvious, follow the gravitational breadcrumbs, and pay attention to the odd motions of things influenced by planets we haven't even seen yet. What if those ancient clay maps were right? What if the old texts, the ones we've mostly brushed off as myth, actually preserve real knowledge, details pressed into tablets like VA 243, waiting for us to finally catch up and spot the world they point to? And if we do find it, what then? Does it prove Sitchin was right? Does it mean ancient astronauts were real? That the Anunnaki landed here? Not exactly. Finding Planet Nine wouldn't suddenly confirm alien visitors. It would just show that the solar system is stranger and bigger than we thought, that hidden planets can lurk out there for centuries, and that our old models missed something. But it would also say something else. It would mean ancient people knew things they shouldn't have been able to know. That stories and diagrams and cuneiform texts preserved real information about the outer solar system, knowledge that somehow survived through myth and legend, waiting for us to rediscover it. And honestly, maybe that's enough. Enough to make us rethink what we thought we knew. Enough to make us wonder if the impossible stories hide memories of real encounters, real observations, or knowledge handed down from somewhere else. Maybe it's time to admit the ancients recorded astronomical data beyond what the naked eye can see. Maybe their maps were more accurate than we ever gave them credit for. All across the American Southwest, California, Arizona, New Mexico, you'll find astronomers hunched over their screens, locked in on the darkness beyond Neptune. They sift through the latest data from infrared surveys, track the faintest shifts in distant objects, and slowly build their case. With every new discovery, their argument gets a little stronger. You won't hear them mention Anunnaki or ancient astronauts. Their language is all about gravitational quirks, orbital resonances, and the wild dance of trans-Neptunian objects. They write for journals, stand up at conferences, and keep their words precise, careful, peer-reviewed always. But the hunt doesn't stop. There's a kind of quiet obsession in the way they stack up data points, tighten the math, and close in on the patch of sky where Planet Nine could be hiding. And you have to wonder, in the middle of all this patient science, are we following a path first mapped out 4,500 years ago? Somewhere, long ago, someone pressed a stylus into clay, recording what they knew because someone had shown them. Someone who'd already been out there. Someone who left behind a code we're only just starting to crack. Out past Neptune, the Kuiper Belt stretches on, a cold, sprawling ring of rubble left over from the solar system's earliest days. Dust, ice, dwarf planets all circling out where sunlight barely registers and the stars cut through the darkness, sharp and clear. And in all that emptiness, patterns start to pop up. Orbits that line up, clusters that shouldn't be there. The math points to something big. Gravity tugs at the edges. Something heavy is out there, shaping the far reaches of the solar system, herding objects into neat lines that shouldn't exist, carving order out of what should be chaos. We call it Planet Nine. It's just a placeholder, really. We only know it by its fingerprints, equations, probabilities, hints in the data. No one's actually seen it yet. But we keep searching, pointing our best instruments at the void, looking for the faintest heat from an object billions of miles away. We do this because the evidence stacks up, the math makes sense, and the patterns don't lie. And if we find it, if the search pays off and some telescope finally catches the thing itself, what then? Will anyone remember that the Sumerians may have drawn it first? Will we admit that maybe, just maybe, we're rediscovering knowledge that was somehow already known, pressed into clay while the rest of the world was still dreaming? Will we even ask how they knew? Or will we look back at those old myths, those stories about visitors from the stars, and finally wonder if they were more than just stories? Maybe the memory of gods walking among us, teaching us to read the sky, isn't as far-fetched as we thought. Maybe we're only now catching up. Look up on a clear night and there they are, the stars the Sumerians named, constellations they mapped with a kind of cosmic logic we're only starting to grasp. Somewhere way out past Neptune, beyond the Kuiper Belt, out in the frozen black of the outer solar system, there's a planet. Maybe it's still out there, tracing its ancient, lonely path, swinging in from the dark on a clock that ticks in millennia. And maybe, riding that orbit, there's the memory of visitors who came here when the world was young, who taught, built, and then left. They didn't just vanish, they left behind clues. Maps pressed into clay, monuments raised in stone, questions echoing in every artifact. Where did the Anunnaki come from? The Sumerians didn't just wonder, they answered. They carved it into VA 243, pressed it into MUL.APIN, hid it in numbers and alignments meant to outlast empires. They drew maps, marked the stars, pointed to the sky and said, "There, that's where they came from, that's their path. That's the planet circling out there in the dark, returning on a cycle so long you need lifetimes to see it." They did everything they could so we'd know. They made it permanent. Now the maps sit in silence. Clay tablets rest behind glass. Monuments still line up with the heavens. Cylinder seals gather dust in museum basements. All of them patiently waiting, pointing toward a truth we've spent centuries dodging, because if it's real, it means we weren't the first. We weren't alone. We didn't build civilization from scratch. We inherited it. Someone handed us the blueprint, and all that's left are the maps to prove it. What if the Sumerians had it right? What if those coordinates actually match something real? What if Nibiru is out there, orbiting exactly as they described, carrying the Anunnaki through the cosmic night, waiting for its return, just like the old texts promise? And what happens when it finally swings back, when we can't ignore the evidence anymore, when we have to admit the maps weren't just stories? Maybe we were never alone. Maybe the knowledge was a gift. Maybe the gods who came down from the sky were just that real. They left the proof behind. Clay inscribed with secrets, stones aligned to distant stars, waiting for the day we finally decide to look up. Waiting for us to follow the coordinates, to see what the Sumerians saw, to understand what they tried so hard to preserve. That's the answer to the question. Where did the Anunnaki come from? It's the truth we've been stashing away in archives, calling it myth, locking it in the dark while the evidence waits, patient, permanent, for us to finally see what's been right in front of us all along.